Hey, welcome back to Coding Nuts and Bolts. And in this series, we're going to learn how to code quickly by taking the top 20% of coding concepts that are going to help us learn 80% of coding. The first part of this series, we're going to learn how to set up our coding environment. However, today we're going to focus on a very important question, which is, what is coding? Do you actually know? Let's explore that together. Hey, welcome back, and if you're here, you're coding with Paris. In the first part of this series, we're going to learn how to set up our coding environments, whatever that means. But of course, boys and girls, before we get into the nitty-gritty of all things coding, we need to first level set on a very important thing, which is, what is coding? I can tell you right now, coding isn't this, it isn't this, and it isn't this. If you remember the first part of our series, one of the things I shared with you was that there are a lot of misconceptions about coding. And quite frankly, it's a lot of things about those misconceptions that make coding seem intimidating or impossible for those who are on the fence about it. But the truth of the matter is, coding is fun, coding is simple, not necessarily easy, but it's something that can definitely open doors for you. One of the first things we're going to do is level set about what coding actually is, right? Cleanse our palate, so to say. Start from that foundation, and then from that foundation, then we're going to start building upon that foundation to get these coding concepts down as quickly as possible. Let's dive in. Okay, let's get something squared away right away, which is, what's the difference between coding and programming? Well, I'll make it easy. It doesn't matter. It really doesn't matter. My shortcut for thinking about the difference between coding and programming is that programming or a programmer is more of an old school way of thinking about things, using old schools of thought, where coding is kind of a new school of thought, maybe less complex way of looking at things. So we talked a little bit about what coding is not. It's not the way it looks in some of our favorite TV shows where someone is clickety-clacking on a keyboard and things are just magically happening. Coding has been around for quite a while. The way it used to exist back in the day is way more complex than it is now. It's definitely not solely for the super intelligent. It's definitely not solely for the stereotypical male who is kind of this big fat guy with a pocket protector and thick glasses sitting in front of the screen. No, lots of really cool people code. And the fact of the matter is lots more people are going to need to know how to code in the future, in my opinion. Side note, who were the original OGs of computer programming? Women. And the funny thing is right now the industry doesn't have a lot of women, which is always perplexes me, because I think the industry could do well with a good mixture of both males and females in there, for sure. But no matter who you are, no matter what your walk of life is, it doesn't matter your age, it doesn't matter what your previous career was. If you want to learn how to code, you can do it. It doesn't matter if you've never coded before in your life. If you're interested, if you have a love for problem solving and you have enough patience to sit down and try things over and over again, you can learn how to code. Simple as that. So we talked a little bit about the difference of programming and coding. I will use them interchangeably in this series over and over again, so just don't get confused. Coding is programming, programming is coding. A coder is a programmer is a coder. Catch me outside if you have a problem with those definitions. Let's keep going. We talked about coding versus programming. Let's talk about coding at its simplest terms. If anyone from the street were to ask me to explain coding in the simplest definition possible, coding is a simple act of just giving your computer instructions, literally telling it what to do. That's it. Nothing more complex than that. Clear as mud, right? Now remember, computers could be your phone, could be your actual laptop. It could be pretty much anything that can take those instructions, that can run software, take those instructions and do things, which we'll talk about a little bit later, but just wanted to kind of break it down to the simplest term. Where the complexity actually comes in, though, it's where you're actually using the coding, right? Are you using the coding to write a little thing for a tiny little robot sitting on your desk? Or are you using the coding to make a game? Or is that coding being used to fly a plane or handle the emergency stop instructions on an electric car? Those complexities start to become what actually drives the complexity of your coding. In those cases, we'd be able to take those simple concepts that we're going to talk about in this series as your foundation, and then actually for any actual task that you'd like to carry out, you'll have to learn the additional complexities and things around those particular aspects of where you're going to apply your coding. When we give our computers instructions, we don't give our computers instructions in plain English. What we do is we use a programming language. What is a programming language? Well, a programming language is a language that your computer understands. Now, there are different languages out there, tons of languages out there. And again, those actually also depend on the paradigm of what you're trying to do your programming language. They can also be very simple, very complex. Now, we're going to use a particular programming language in this series called JavaScript. And we'll talk a little bit more about that in a second, but the importance of languages is that they help us talk to computers. Programming languages used to be ones and zeros back in the day, but they've evolved quite a bit over time and become way less complex. Now we can do things like give our computers instructions in something that almost looks like English. And then that language is broken down into the ones and zeros that the computer understands, and the computer then follows out the instructions that we give it. If anyone were to ask you to explain how programming languages work, this is a good shortcut in thinking about it. We give the computer's instructions via computer language. Though that computer language is then translated to something that the computer understands, and then the computer performs them in order until its task is complete. That's essentially how it works. As far as computer languages go, I would suggest that you learn maybe 2 or 3 computer languages very well, or at least have a really good understanding of 2 or 3 computer languages. Keep those in your pocket. That will make you very viable in the marketplace. But you don't have to know them all. In fact, the cool thing about what we're doing in this series is that the concepts and things that we're going to be learning are going to apply no matter what the programming language is. Because once you learn one, you pretty much know all of them. Again, what makes you more marketable is the nuance of what you're using that computer language for. What is your specialty? What do I mean when I say once you learn one language, you learn them all? Well, a good way to think about that is there's something called syntax and there's something called semantics. Syntax would be the actual characters, the words, or the sentence structure that makes up the computer language. Semantics would be what exactly you're telling that computer to do in that language. Now imagine that we are talking about computer languages as if they're actual languages. You already know when you're learning a new computer language what you're trying to say. In every single language, there's a way to say sit down. In English, you would say sit down. In Spanish, you would probably say siéntate. In the world of languages, syntax is actually Spanish versus English, where semantics is more of what are you trying to say. And so the reason why once you learn one language, you know another is because you already know when you're learning a new computer language what you're trying to say. Semantics. The task is trying to figure out how to say it using the new computer language structure. Syntax. And they all look very similar. So we talked a little bit about computer languages and what they essentially are, which is a way to give our computers instructions. We talked also about how the languages are broken down from the instructions that we give it into something that the computer understands in order to carry those instructions out. Finally, we kind of talked about the fact that there aren't a lot of differences between the languages. So if you learn one, you probably learn the other. But let's circle back to what is JavaScript. JavaScript is a computer language. It is a language that is used to give the computer instructions. It's a very popular computer language, which is why we're going to use it as one of the first and foundational languages that you should learn at the beginning, because I secretly want you to be super marketable right away. But also because JavaScript is one of those languages where the syntax, right, the language is easy to pick up. The structure is easy to pick up. The way you use it is you can set up your environment and run on that very quickly. and you can just get going right away. Also, one of the coolest things ever about JavaScript is that its popularity is shot up so much that there's barely any devices that exist today that don't run some level of JavaScript on it. So, I mean, that goes from phones to TVs to pretty much anything you can probably think about can run some level of JavaScript or can understand that JavaScript language. So this is why we're using this particular language. This is probably a little boring, but just a little history lesson on JavaScript. It was invented in 1995, and its original intent was to actually be used for just working on your web browser. But since then, it has been expanded, like I said, to work on pretty much anything and any and everything. So learn JavaScript, you're golden. So let's bring things full circle to kind of wrap this video up of what you learned about computer language. The first thing that we kind of talked about here is the simple fact that there's no real big difference between a programmer and a coder. And there's another one that I didn't mention before, which is called a software engineer. Oh my goodness. Those are pretty much all the same thing. One might argue that one requires a little bit more discipline than the other, but for the purposes of what we're going to be talking about from now on, same thing. We also talked about the simple fact that coding, it's not just for the super intelligent or super smart. Listen, I've been coding for over a decade, and I would never declare myself super smart in any way. I just love to solve problems, even if that requires me to do super redundant tasks. I like to work at those, and I love the satisfaction of figuring it out at the end. It is definitely simple but not easy to learn how to code, but anyone from any walk of life can start coding. We also talked about what programming languages are, how they work. A simple way to think about that is programming is simply giving your computer instructions. A programmer gives those computer instructions professionally. A programming language is broken down, is basically in your instructions broken down to a way that the computer can understand. And there are several different languages out there that get more complex based on the paradigm of which you're applying at programming. Like I said, it can be super complex because if you're using that coding language to power a rocket to Mars or to handle safety protocols on a airplane or a car, versus if you are using that programming language to handle clicks on the screen or to power a little bitty robot that you're using to walk on your desk. Lastly, we chatted about what programming language we're going to be using in this series, which is JavaScript, and why it's super cool to actually start out learning JavaScript as your beginning intro to programming class, because JavaScript is one of the most versatile, most used languages out there, and it's easy to learn and move forward. We talked about what programming is. In the next part, we're going to actually start setting up our coding environment so that we can start coding. All right, see you next time. Peace.